Give me a moment. Sudhir and guys, sir. Yes, Prerna, you are correct. Sudhir, I think, just give me a moment. When did I share it? I think 6th, 7th October. No. So if you closely observe, there is one folder inside the zip file called exercise files.zip. So in that, all the data sets are present. If you are not getting it, just let me know. But as far as I remember, I have shared the data files additionally. Yes or no? Yes? So Sudhir, please check it. Now coming to this ISO encoding issue. So what you're supposed to do for that is, just listen to this. Just go to File, click on Save As. Here, by default, what you would find is Windows will be putting this ANSI encoding. Just change it to UTF-8 and save it. That's it. So you have to replace that file. Yes, and that's it. Now that will be read by Python.
So we don't have to put it as CSV.
Which one? That you have to put anyways. See, whatever. Oh, come on, man. Why are you confusing me? Whatever statement you are writing, that was not reading the file. That is the problem, right? Because it is showing some UTF error. So just change this one, save it, close it. Now rerun the same code in Python, read _CSV. There you have to put .csv. Without .csv, like these things will not work.
Or you can give an encoding.
Encoding also we can give in the.
But it works only in Mac.
Yeah, it's working in Windows also.
In Windows system it is working. In most of the system it doesn't work. My system doesn't work. Even if I put encoding is equals to UTF-8.
No, I
It's
got one more.
Use CP1523.
उतना research हम नहीं करें ना. वही that's the problem.
Yes. So many SOP should be like this.
Pardon?
If you get some error like this, SOP should be like this.
See, the problem here is always with the encoding. Like let's say I have worked with a lot of European data sets, names and all, especially the Nordic names or what do you say, data from any European nation. They have these different letters in English, different Latin letters. That always causes this problem. So either I have to change my source files, which is always set to UTF-8 anyways in their systems, because like how we can see English US here in Windows, they have their own language, right? So that language incorporates those encodings. Our systems, it takes ANSI as default. So I'm not able to see how to change that or make it permanent UTF-8. That's the only file. Every time I read, every time I share this file, that's a problem always. But yeah, you can do it in that manner. Of all the things that we had discussed before, like connecting to data sources and all, DBMS, I'll ask Mr. Chandra to discuss it because he has MS SQL in his system. He'll quickly show you how to connect with that system. I am still not able to install it in my system. That's the problem. And the remote database that I have, that's slightly confidential. I can't dare to connect it. And like there are a lot of sensitive information which I don't want it to get recorded. That's why I'm not able to connect it. So nonetheless, I mean, like that's a small part of code. Even by now, most of you would have researched on it, I guess, because we have learned so much of Python till now. So I think some of you would have tried to connect it in your workplace if you have any DBMS, right? But in any case, we'll be discussing, Chandra will be discussing that with you, right? And JSON files as well. I'll ask him to do that. I'll not discuss this importing anymore. I'm done.
Sunit, one quick question.
And coming to the class schedule, today and tomorrow we'll be having classes. So today we'll finish up statistics. Tomorrow we'll begin with linear regression. Not exactly linear regression. We will see what is in store for us in the next upcoming classes. So tomorrow's class will be highly important if you really need to understand what kind of predictive modeling we'll be doing in future. right? So we'll get started with those. I mean, like we'll touch base each and every technique, and then next classes after that. I mean, like after that you will have holidays. I think you will have an off on 20 and 21st. So 27th onwards, your machine learning begins with linear regression, right? So tomorrow's class we will be seeing in brief what each and every technique is all about. That's it. We'll be learning the formulae, right? We'll see its application areas, and then we'll go in depth. And at the end of this entire exercise, it might take like a month, right, to complete all the concepts. Once that is done, you should be in a position to see a business problem and identify what kind of problem that is, right? That's the ultimate goal. Now today, let's get started with our topics. I think in the last class we had actually stopped at what point? Z transforms. Okay. Okay, let me open this. Just give me a second. So we were here, right? And I hope everyone is able to understand this problem, what we have done and why we have done. Let's have a quick look at the milestones that we had covered till now. That's a better way to see it, right? So our first starting point . So first starting point would be at descriptive stats, right? We'll understand what is mean, median, mode, right? How it is derived. We understand what is standard deviation and variance. It's measures of dispersion, right? So that was our first starting point. Then we moved on to the next one, where we try to understand one thing, that not always the entire data can be used. So if I can call this as descriptive stats. So after doing descriptive stats, we realize that we don't have access to the data always, or sometimes it's always it's difficult to work with entire data together. So what did we discuss here? We discussed something about sampling, right? So here is where your inferential statistics comes in, right? So first of all, sampling. We try to understand what is a simple random sample, what is a stratified sample, and what is a grouped sample. Now, after doing this, we understood that sampling is all about estimating. Sampling is all about estimations, right? We are not trying to find out the exact things. Yes? So that's why you had point estimator or interval estimator. And we have understood what's the difference between point estimators and interval estimators, right? I have given that exit poll example. One can predict the exact number of seats an XYZ party will win, or you can come up with ranges, right? That's what is, interval estimation is all about. Now, here we had a branch out. If there is an interval estimation, my interval should not be too small, or my interval should not be too large. They should be in a perfectly explainable manner. So if I take a number line here, if this is my extreme points, if these are my extreme points, I can't tell that my interval will lie between point A and point B. No, that is totally incorrect. Point A and point B, these are the extreme points. If I say that my interval lies between these 2 points, that's completely baseless, right? So I'll have to choose one intermediate point here. Like for example, this blue line here on my left hand side, and this blue line here on my right hand side. Now if I can say that my data is falling under this range with an error of, let's say, 5% on either sides, and a total error of, let's say, 10%. See, you're able to observe, right? There is a 5% error on both the sides, right? Plus or minus 5. And not 90%, I'm so sorry, 95%, right? So plus or minus 5% error if I can detect a range like this. So yes, I can be 95% confident that my estimation lies between this point here, let's call it as X, and this point here, Y. Clear? So in interval estimator, we come across a concept called confidence interval. Is that clear? Or sometimes we will use the word alpha to denote 1 minus confidence interval. The 5% error that we are saying, we will not call it as error. That's not the correct word to use. We will be using the word alpha. Right? Is that clear? Online guys, any questions so far? Any questions so far, online guys? Hello? Okay. Now, once this was done, our next journey point was here. After we found out the interval estimators, we had to see one thing that, okay, you are fixing with one interval estimator like this. You have to prove one thing now. So you have to prove that this is correct. Yes or no? You have to prove that your estimation is correct. So here in this destination, we have to see whether my population information that I have, population info, whatever I have, is that correct? Or whatever sample you have taken, is it correct sample or not? I mean, like, correct sample or not, initially, like, we will try to prove that if mathematically my results are not coming proper, I'll conclude that the sample that I've taken might not be correct. So business logic wise, I'll rethink what mistake I might have done. Like that handbags example that I keep giving. So if I have taken more males for doing any kind of market research on handbags where the most of the users are females, then I have taken a wrong sample, right? That's a very simple example to take. So your sample being correct or not depends mathematically and also intuitively, like when you look at the business logic, right? So this is what we'll be proving here. And this entire thing is known as hypothesis testing. Test of hypothesis, right? Now, if you want to do test of hypothesis, you have to understand a lot of theory from this point onwards. So we should be now able to understand something called probability distributions, which is required for here. So that's one more important journey point, our probability distributions. Correct? And after probability distributions is done, you have to understand that what is normal distribution and what is its standard form. Standard, normal, and Z transforms. This is what we have done in the last class, end of the last class. So I hope everyone understands what's a probability distribution, right? Right? You take every data interval at a granular level, try to plot a histogram, and try to connect all the tips of the bars of histogram. You will end up having a curve. That curve is probability distribution curve. And like we all know, every curve has an equation. This curve also has an equation which is known as probability distribution function, PDF. Probability distribution function. Now we have also seen that 95% of the data follows top 20 distributions. Yes? So if it follows a distribution, it will have an equation. These distributions, these 20 distributions also have one predefined equation, right? If I have 20, it's always easy for me to find out the equations of these 20 patterns, right? So your curve will come, your curve equation will come close to that equation. Is that clear what I'm saying? Right? So once it comes close to that equation, then any curve will, I mean, like we can easily determine what is the probability distribution function of any curve. And if we can determine that, we can easily find out probabilities. And if we can find probabilities, then that will be very much helpful for our hypothesis testing. This is all linked now. So point estimators or interval estimators, we will do hypothesis testing to prove if my population info is correct or sample is correct. For that we need probability distribution curves. Yes. So probability distribution curves gives you probability distribution function, PDF. This probability distribution function is helpful for me to find out the probabilities, yes, which in turn helps in hypothesis testing. That's the cycle here. Is that clear? Yes. So today what we will discuss is, we will discuss what is the reason why this entire cycle is possible in the first place. What made this cycle possible, and that reason is central limit theorem. Right? Central limit theorem is what is something making this entire cycle possible actually in the first place. Right? And in layman's terms, if you can just look at CLT, CLT says that more is the sample size, more accurate is the result. In layman's terms. But that's not the meaning of CLT. We'll discuss that, what actually CLT means. Who is drawing here? No, Prerna, it's not 90. I mean, like, we'll discuss that when it is 90 and when. So see, here you have 5% on either sides, right? When do you call this as 90% and when do you call this as 95%? We'll discuss that, not now. But yes, first we'll have to go to CLT. Then again we'll revisit our confidence intervals and alpha, right? Where we'll be discussing something about tails. And that's when I'll talk about this. Whether this is 5 plus 5% or overall 5% when we talk about tails. Now once we do that, let's understand what is z-test or t-test, then ANOVA, and finally chi-square. And we will do a case study on that. Clear? Alright, let's start. All right. So I hope this slide is clear to all, right? Point estimators versus interval estimators. The reason why I'm saying this is highly important actually for us to know, right? To understand confidence intervals, this is a very important thing to know, and to perform your z-test, this is also a very important thing to know, right? Now, let's look at central limit theorem. I'll explain it in the easiest way possible. Let's say there is a population of 10,000 people or 10,000 elements, population of 10,000. Its distribution can be anything. That's my first point. The distribution of this population can be anything. It can be Poisson, it can be binomial, hypergeometric, any distribution, right? Gaussian, Bernoulli, right? Any distribution, log normal. Clear? Now, what I'll do is, I'll take sample S1. I'll take a sample S1, right? Size, let's say, let's fix our size to size something which is greater than 30. So let's fix it as 30, for example. Right? I have taken a sample S1 where n is 30, size is 30. Clear? And I have found out mean of that sample, mean of sample. Right? So let's call it as mean of S1. Right? Or let's say mean underscore S1. This is what we have here. Now this population will also have a mean underscore population. This population will also have a standard deviation. Yes? We'll come to that. Now taken mean of S1. Like that, I took one more sample. So there is no harm in taking a random sample again, right? So this time I'll call it as S2, and this time also I'm taking size 30, and I'm noting down the mean. So mean is now mean of S2, right? I hope you're able to understand what I'm saying, isn't it? I've taken S3 now, where n is equals to 30. One more sample, and I'm noting down the mean of S3. S4, n is equals to 30, mean of S4. So I hope you're able to understand what I'm doing, right? I'm taking various samples. I'm taking various samples in a variable, finding out its mean, and just discarding that sample for a while. I'm not considering that sample anymore. So every time I take a sample, I only will have 30 elements out of the entire thing. It's just that I'm noting down the mean and discarding the sample, right? So what is your sample size, overall sample size? It's not 30 plus 30 plus 30. No, I don't have that much information. I only have 30 at this moment. Let's assume that, right? On a very simplistic scale. My overall sample size is 30. It's just that I have taken this sample of 30 many times. That's it. I hope you're able to understand what I'm doing here, right? And I've calculated all the means. Yes? Now, after doing this, in the final step, what I'll do is I'll find out mean of all these sample means. Mean of S1, mean of S2, mean of S3, and so on till mean of Sn, right? So let's call it as mean underscore samples.
And each of S1, S2, S3 are unique, right?
They can be repeats, it's fine. There is no hard and fast rule. It's just that S1, all the elements of S1 might not be equal to all the elements of S2. This will never happen, that out of 10,000, if you're picking 38 random, you can pick infinitely 30 elements from 1 to 1000, right? So there will not be any chance of repetitions, right? But yes, nonetheless, I hope everybody understood the idea behind doing all this, right?
Yes, we need
How I have done it. Taking sample 30, noted down the mean, threw it off. I threw it off as in put that back into the population. Again, I'm taking randomly 30, noted down the mean, and put it back. Now, what central limit theorem says is, if I plot all these means, first postulate is mean of all the sample means, irrespective of the population distribution, will follow a normal distribution. Is my population normally distributed? Can be or may not be. But all the sample means taken together, they all follow a normal distribution. That's the first postulate of central limit theorem. Second postulate is, if it is following a normal distribution, it will have an average and standard deviation, right? The mean of samples, you understand what is mean of samples, right? I have written there over there. Mean of samples is almost equal to mean of population. This is the mean of samples, and that is its formula. I hope everyone is able to note it. Yes? So the mean of all samples is equal to mean of population. I haven't said equal to, I said almost equal to. Is that clear? When I say almost equal to, there is some error, right? And when I say normally distributed, there is a standard deviation, right? So this standard deviation is known as standard error. So the STD of all samples is called standard error, denoted by the formula SE is equals to standard deviation, STD of population divided by sample size. What is the sample size here? 30. I hope that is clear. These are the three postulates of your central limit here. I want you to please look at this again carefully. So just reiterating every doubt still here. First of all, sample size n is equals to 30. Is that mandatory? Theoretically, yes. What if n is not equal to 30? Is CLT not applicable? The answer is yes, not applicable. There is a slight twist to that, right? We will try to change some of these definitions, that's it. So CLT is very much applicable if n is less than 30 with a slight change in the definitions. Are these samples taken in random? Yes, these samples are taken in random. What is the maximum size of these samples? It depends, right? What is the best example of CLT? If I say, like, if petrol prices is unknown for me in a particular country, right? Sorry, petrol information is known. So that case, its population information is known to me, right? But I have my population information. I have my population standard deviation, right? So in that case, what I'll do, I might try to take some samples and try to prove if my population information is correct or not. That's one side of the story. The other side of the coin is, I might not have population information at all. So petrol is something which is known. Petrol, gold, silver, these rates are known because they are internationally traded commodities, right? So let's say rice, for example. Rice is not a commodity that has to be traded, right? So let's say you wanted to find out what is the price of rice in India, and you don't know the information of it. So you will take random samples. You will keep calling a lot of retail shops and maybe try to find out what is the per kg cost of rice, and then arrive to a conclusion. How did we arrive to the conclusion? Of all the samples that you have taken, you have one point, right? Let's say somebody is saying 10 rupees, somebody is saying 40 rupees, somebody says 70 rupees. You find out mean of all the things that you have found out, of all the points that you have found out. So mean of those points will be equal to your population mean. This is what central limit theorem says. Clear? Yes? So one way of the coin was to prove that it is correct or not using samples. For both the things, CLT will be helping you with that. Right? Now CLT gives rise to two tests. One is a z-test, the other is a student's t-test. Z-test and t-test. Clear? In both the tests, what we'll try to prove is, if we have a sample, we try to prove if this sample is correctly representing the population or not. We'll try to prove if the sample is correctly representing the population or not. Meaning if the sample mean is significantly different from the population mean. If the sample mean is significantly different from the population mean, then sample is good or sample is bad? Sample is bad. Look at the word. I never said that sample mean equal to population mean. I never said that. I just said if the sample mean is significantly different from the population mean, then I have taken a bad sample. Or this can also mean, or it can also mean signify that the population information that we have is incorrect. Either of these things, like I have said, it's a two-way street, right? Either your sample is bad or your population information is incorrect. Let's say I said like the gold price is 3,000 rupees per gram, and you go and buy gold and you'll get the shocker of your life. It's not 3,000, let's say it is 2,000. It never happens in real life. What did you have here? You have an incorrect population information, that's it. Is that clear? This is your z-test. But the most important point here is, and you have to always please remember that, z-test works if and only if sample size is greater than or equal to 30 and we have the population mean and standard deviation. You know what is your population mean and standard deviation. So for z-test, it's always a one-way street. For a z-test, you must have your population information. Population mean and standard deviation is known. Then only you can apply z-test. Plus, your sample size should be greater than 30. Both the conditions must be satisfied. That's mandatory. Now, if you might ask, what if my sample size is not 30? And what if I don't have population information? Or what if I have both the things, both the conditions not getting satisfied? In any of the case, if we don't know, if you don't know the population information, or if the sample size is less than 30, or both, then we use students t-test. So this small sample does not follow a normal distribution, it follows a t-distribution. This data follows a t-distribution. Whenever you're taking a smaller sample, it follows a t-distribution. I mean, like, you can have a curve like this. Let me tell you. So if this is the case, you can have a curve which is like this, see, which looks near normal, or you will have a curve like this. This is a t-distribution with limited samples, or too wide like this. One second. This can also be a t-distribution, right? So these are your t-distributed data. This usually happens when you have considerably lesser amount of samples. And again, I'm saying 30 is taken as a theoretical limit. 30 is the magic number for stats samples. Clear? Now, yeah, I'm sorry. Yeah, please tell me.
When you talk about population, it's a theoretical number given at the project, a company or the client as a business problem, which is currently an outcome of secondary research. But sampling is something which is a part of
primary research.
When you actually do the project analysis. So when you actually in the market, we are sending questionnaire, getting the data from the real-time people. And then
so I'm not interested about population size. Whenever I say population information, I'll never talk about size of the population. In my mind, the size of the population is always close to infinity. In my mind, I'll never talk about population size. But I'm really interested at population mean and standard deviation. Now, if you're wondering how can we get it, you know better than me. Secondary research. So some things are known already, like I have told you this gold rates and petrol rates. Or please turn off your mics. Uttam, please turn off your mic for a while. I'll give you a chance to speak. So either you know the information or you calculate the information through your secondary research. So that time the sampling becomes a part of your secondary research, not your primary research. That's not your goal. Your goal is to first have a base, have a ground first, right? Get the population information. Then maybe you'll do, like, let's say, you wanted to understand how many males and females are there in Bangalore before you get into a market analysis. And that time you have to actually take a sample and find out what is the total percentage of males and females in Bangalore. Let's say if you don't have the population information. Usually this information is available because somebody else does that research for you. The government does that research for you, and it releases that sex ratio thing. I hope you're able to understand, right? Based on that, you can run your campaigns. Let's say your product is not gender specific. It's okay. If your product is gender specific, you can run your campaign on those kind of people. So if you're taking a sample, you'll just ensure that, let's say you are maintaining that 48-52% of ratio. 52% male, 48% of female ratio. I hope you're able to understand this, right?
But when it becomes sample, we make it a point that it is characteristically same as a population data.
Stratified sampling. This is what it is.
But in spite of that, if we end up
Exactly. So that's the point where I should be getting it.
in spite of that,
Pardon?
it's a bad sample then.
Yes. So you'll conclude that it is a bad sample.
But population and sample both are characteristically same.
How?
In terms of the parameters that are taken, gender, age group.
So in that case, I mean, like these two things will not be significantly different, right? Your z-test will pass in that case.
Should it always pass?
Yeah, that is what the theory says, right? Why will not it pass? It will, right? It is bound to pass it. Or still, you'll like even if you're taking like let's say for example, you are trying to sell a watch, which is made for men. Now, let's say you have taken a sample and still it is not coming correct. Now your business logic should kick in. Which kind of people did I take a sample? Let's say that watch is priced at around 10,000 rupees. And you have collected information from a lot of people who are students, let's say. A student might not be able to afford 10,000 rupees for a watch. Maximum he or she can go is like, let's say 2,000 rupees. 10,000 rupees is out of reach. So you have taken a wrong sample despite maintain. So now another group should kick in.
So one of the regular characteristics.
So it all depends on, again, like primary research. Now you have to see like which is your target audience. But if you have made sure every point from your business logic, this is never going to fail. This is what has been proved empirically, right? These all are empirical theorems, which has been proved time and again by both mathematical induction and both by practical tests. These will never fail, right? Now, coming on to one by one. Uttam, yes, please tell me, what's your doubt?
You said that the central limit theorem gives you a normal distribution of all the means that you've taken.
Exactly.
Is there any assumption on the population distribution, or it can be anything?
Anything. So that's the first point I have mentioned here, right? Your distribution can be anything.
Okay, thanks.
Yes, Prerna, what's your doubt?
As you mentioned in point 2 that say for
Prerna, just request you to be a little bit louder.
okay, so as in point 2 that you have mentioned that there will only be two reasons that my z-test or t-test will fail. I mean, if my population mean is different from, I mean, whatever mean I've got from the sample is different from
Significantly different from population
mean, then my sample is bad, right?
Or my population information is incorrect. Yes.
So what do you mean by population information is incorrect? Is it not considered?
Like let's say you are going out now to buy some gold.
Yes.
And let's say you visited a website and it said that the gold rate is 3,500 rupees. For example, or maybe like somebody told you that the gold rate is 3,500 rupees per gram. ₹3,500, for example. Or maybe like somebody told you that the gold rate is 3,500 rupees per gram. Now you go and buy gold and you realize that it is not 3,500. It's rather, let's say 3,000, not 3,500, it's 3,000. So what went wrong here? You had a wrong information about the population, right? This is what I mean by wrong information about the population, or not having any information about the population. Let's say you're visiting an unknown place, like let's say I'm giving you this rice example. Rice is consumed by other Southeast Asian nations. Let's say you're going there for a longer period of time and you wanted to estimate what is your expenses for food. You don't know how much rice and vegetables are going to cost. You don't have the population information with you. So that is what I mean by having no population information or having wrong population information. I hope that's clear.
Okay. Thank you.
Online guys, I hope this is understood. What is z-test and what is t-test? Online guys, is this understood? But I hope everyone is able to understand, right? Yes, Siddharth. Thanks for raising that point. So t-test is always applicable. I would say to some extent, yes. I mean, like I can't give an official statement that t-test is the best or t-test is the only thing available. No. But if I look at the functions given by R or Python, so like Python has a function t_test or like, you know, something like this. R has a function called t.test. So they will never use the word z-test. So depending on the inputs that you are giving, it will tweak itself. If you're giving a good enough sample, t-test will tweak itself and refer to the z-table. We have referred to z-table before, right? If the sample size is less, it will automatically tweak itself and refer to the t-table. There is another table called t-table, right? It will refer to the t-table now. That's how it works. Automatically it will do that for you. Number one. Number two, all these things that we are discussing or all these z-test, t-test that we are about to discuss now, you don't have to do all these things. Your software does that for you. But you have to understand what is going on inside, right? Without that, we can't move forward. All right. Now let's look at an example of z-test and t-test. Yes. The example that I will be giving for z-test, please imagine the situation here. I will be giving it on petrol prices. Somebody is visiting a city. Melbourne is the example that I have taken here, right? So just imagine yourself in this situation. Your company is moving you here for next 6 months. There they're going to provide you car, accommodation, everything, but they have this like, they're like, you have to pay for your own petrol, they say. So you will estimate your budget, how much should I be needing for the petrol, right? So somebody tells you that if the petrol price in Melbourne is 92 in their currency, let's say it's 92, and you ask, are you really sure it is 92? I say like, plus or minus some figure. Standard deviation. So what is this? This is your population mean. This is your standard deviation of population. Right? Now you wanted to really make sure, that this information is correct. So what did we do? We did a sample. After doing a sample, we found out what is the mean of sample. Right? Now we'll try to prove, and sample we have taken. So what we did, we took up our phone, took out the Yellow Pages book and randomly contacted 50 petrol pumps in the city of Melbourne. There can be more than 100 petrol pumps, 200, let's say 200, 300. I can't call all the 200 or 300 petrol pumps. I just randomly called 50. Right? So everyone will tell a price, right? And that's the average for that sample. If I'm calling one petrol pump, if they're telling me one price, that's the average, right? 1 point which is representing everything. So the averages for all the averages that I've taken, I got my mean sample of all the 50 petrol pumps. Is that clear? Yes. Now I'll try to prove if is the petrol price really 92 now, because this mean of sample I got it as 93.6. which is close to 94, right? So try to prove is the petrol price really 92? Yes or no? So this is your entire theory, entire problem statement. So please go through this once. Please look at this problem carefully. So petrol price in Melbourne is normally distributed. Okay, so this is my first information that I have. This entire thing is normally distributed, which means your population is normally distributed. Clear? Even if it isn't, I can still proceed with it. Yes or no? CLT, anything can be taken in, right? The average is 92, so this is your population mean, right? With a standard deviation of 3.1, right? So we have written that here, we have mentioned that here. Population mean is 92, standard deviation is 3.1. Now, to prove this is correct or not, we sample 50 service stations and obtain a mean of 93.6 liters, 93.6 cents per liter. Is that clear? Now you have to prove whether this is correct or this is correct. Our only target is to prove this is correct or not. 92 is correct or not. Right? Now please listen to the underlying theory here. Everyone please pay attention. All right. Now we are looking from our perspective, right? You are the one who has taken the sample. Yes or no? You are the one who has taken the sample. So let's consider this point as your base point. So let's say 93.6 is your base point. Is that clear? Right? I'll give you both the perspectives. So first perspective, okay. First perspective, let's look at the normal perspective. 92 is your base point. What do you mean by base point? Your average, right? The average is 92, right? You have found out that the petrol prices of the samples that you have collected, and this is anyways a normally distributed data, the petrol prices of the samples that you have collected is 93, right? Now what you will do is you will just set one limit. You can't go to the extreme ends, you know that, right? You will set up a limit. Let's say you are setting up a confidence interval of 95%. This here and this here. Now listen to this first point of confidence intervals. The first point is, if I'm setting a confidence interval, I need to know which points are those, right? Now what I'll do is I'll Z transform 92. I'll find out Z of 92. In fact, I'll convert the entire curve into a Z curve. I'll perform a Z transformation on the entire curve. So in that scenario, please observe this particular equation. If you're converting entirely into a Z format, a confidence interval of 90% means it is mean as in Z of 92, right? Lies between plus or minus 1.645 times standard error. So if this is Z of 92, what is the Z of 92? 0, right? 92 minus 92 by total size, which is 0, isn't it? So if you're 90% confident, then your estimated value will lie between 1.645 and minus 1.645, right? If your mean is 0, the Z value of your estimation, let's say in our case Z value of 93.6, the Z value of 93.6 should lie between 1.645 and minus 1.645 if you are 90% confident. I hope that is clear. when you declare yourself that yes, whatever sample I have taken is 90% correct, which means from your mean, the z-value of that particular sample mean should lie between minus 1.645 and plus 1.645. Is that clear? Yes or no? If you are 95% confident, that value just increases to 1.94, 1.9, it's 1.96. Now, if you're saying you're 95% confident that whatever sample you have taken, online guys, can you all hear me? So when you're saying you're 95% confident that whatever sample you have taken is correct, it means the z-value of your estimation, which is 93.6, the z-value of 93.6 lies between minus 1.96 and plus 1.96. If that is not the case, then your sample is incorrect. I hope you're able to understand, right? If the z-value of your sample, that is this blue line here, lies between plus or minus 1.96, yes, then your estimation is correct. So these are not significantly different from each other. This is what you will conclude. If this blue line is somewhere here, which means the sample mean and population mean is very much different, right? This is the concept of confidence intervals in practice. I hope that is clear. So you got to remember these words: plus or minus 1.645, plus or minus 1.96, and plus or minus 2576 for 99% confidence, right? I hope this is clear, online guys. Online guys, I hope this is clear to all.
Vineet, just one doubt.
Yes, please.
The mean that you have mentioned is plus or minus 1.645 and like 1.9 and 2.5.
What is mentioned as 1.645? I can't hear you. I am not able to hear that.
Yeah. So are they standard across for all normal curves?
Of course, Z transform. What do you understand by Z transform value? That's a standard normal curve, right?
Okay, fine.
So again, reiterating if there is any confusion, 92 is my population mean. I'm just converting it into a Z transform. So population mean Z value is 0, right? Your mean becomes 0 in a standard normal curve. Now you're also converting your sample estimation to a Z value. So now if that Z value represented by this blue line lies between, like let's say you're 95% confident, so if this blue line lies between plus or minus 1.96, then your estimation is correct. Then your population mean and the sample mean, they are significantly not so different. They're almost same. I'll never say exactly same, but they're almost same to 95% confidence interval. If you're saying it is 90% confidence interval, then it is plus or minus 1.645. Is that clear?
Yeah, clear.
So if this blue line is lying beyond 1.645, if your CI is 90%, then you will say that your black line, which is your actual population, and the blue line, which is your sample mean, both are significantly different.
And that gap is known as standard error.
This gap, any gap is known as standard error because these lines will seldom overlap. There are very rare cases that these lines would overlap. There would still be some error left, right? Even it is 0.01%, there will be some error left. I mean, like you can find, you might have a situation like this. See, you can have a situation like this, but these are not exactly meeting, right? There is at least a small error. If your mean is 92, your sample mean could be 92.3 or 92.4. I hope you're able to understand what I'm saying, right?
I had a hypothetical question.
Okay.
Let's assume you have about 10 million records and you take 30 pieces and we find that it is within the confidence interval, does that mean that is representative? We can confidently say that is representative of the 10 million records?
Uttam, I just request you to please repeat that part. So you have 10,000 records.
No, let's say you've got 1 million records.
1 million records, let's say.
And we take 30 pieces and we know we can compute, let's say it's percentages or something, we can compute the mean and standard deviation of and call that the population.
Okay.
Now we take 30 pieces and we get a confidence interval of within 90% that it is the mean is close to whatever the population is.
Yes.
Does that mean we can now work with the 30 pieces and say, okay, now whatever we are doing is representative of the population?
Exactly. This is what your theory says, right?
I see. Okay.
So you're correct about it. If these 30 samples, the mean of those 30 samples is not significantly different from your 1 million records, mean of 1 million records, then you can simply work on those records. Those are more than sufficient. How many rows are there in the stores data set that I have taken? 32. So it's more than 30, right? So that's a sample that I've taken from a bigger data set. Why did I take 32? It's at least theoretical that 30 is a number which is a good sample. 30 or greater than 30 is a good sample. Is that clear? Okay. First of all, my first question would be, I hope everyone is able to understand the meaning of confidence interval. Yes? Meaning of these numbers, 1.645, 1.96 and 2.57. Yes or no? Online guys? Classroom guys? Yes or no? Come on, you should be more responsive. Your heads. So previously you were shaking your heads well. Today your heads seem to be like fixed. Yes, please.
You were able to make the Z transformation just because the distribution was normal, the population distribution was normal.
Yes.
But then how do we know the population distribution is normal ideally?
So here I have assumed it. If that is not the case, then I told you, right, CLT works on anything.
Yeah, but then CLT works when we take n number of samples. So here, for this case, like 50 is the sample, we are taking only one sample, right?
I
We're
mean,
not taking n samples. We're not calling.
see, it's never about n samples. It's about what is your total samples that you have taken. How many means do you have? So let's say, for example, when I say I have taken 50 samples, so one petrol pump is enough to give me the average price, isn't it? So if I call a petrol pump and if I can simply ask him what's the price, he'll tell me the price. He'll not tell me that like let's say you're asking, let's say you call a shop to find out the price of rice. Now this one shop will give you 30 different prices. Let's say, and like I have a variety A, variety B, variety C. I have 30 varieties, and they'll tell you the price. Now what you will do for this one shop, you will first find out the average by the points that he or she might have given you. Then you will conclude that this was my sample and this was my average of that sample. So it all depends on what you're collecting. I hope everyone is able to get a perspective, right? You call a petrol pump, you ask the price, he'll tell you straightforward. You call a rice shop now, asking for price of rice. The very first question will say, which rice do you want? I said, like, I want to know all the price of rice. So he'll just sit and give you, like, if that shop is selling 30 varieties of rice, he'll tell you all the 30 prices. If that shop is selling 200 varieties of rice, he'll tell you the price of all the 200 varieties of rice. Right? Then how would you continue next? For that particular shop, whatever prices they have mentioned, you will find out the average of it. So that rice situation is this one that I had taken in the example. See, this is that rice situation. Every shop you call, they're giving you multiple prices, so you had to calculate the mean. Now, every petrol pump you call, they gave you one straightforward price. You don't have to calculate mean. And why mean? I told you that mean is something which represents each and every point, each and every data point. Right? I hope the very first day when we discussed the definition of mean. Yes? I hope that's clear now.
That is fine, but then in CLT, nowhere it's mentioned that whatever the distribution might be, we can apply this CLT.
Yes, exactly.
But then nowhere it's the other way around, that if I have the mean of the sample, I can't conclude that my population is...
No, you can't conclude. See, here I have taken this curve because what is the first statement here?
It's normally distributed.
Yeah, the very first statement that is given is petrol price is normally distributed. So in case that is not, yes. So I have told you, right, I will be giving you both the perspectives. I have given only one perspective now, right? So I hope this is clear. For this example, this is clear, right? I'll come to your question now. Online guys, is this clear?
So Sunit, I had a doubt.
Yes, Prerna, yes. Please tell me.
So you're saying that, say, for example, the population mean right now we have is 92, and we do a Z transformation, and then the population mean becomes, the center becomes a 0 with a Z transformation, right? And I set up a 90% confidence interval. So I'll have plus or minus 1.645.
Yes.
Right. So if my the sample mean lies within this range of plus or minus whatever.
Yes. Look at this blue line. If this blue line is lying between,
then I can say that statistically I can say that they are similar. This is what you're saying?
You'll not say exactly similar, yes. I'll say they're significantly close to each other.
So, but how will I measure this? Because I have Z transformed my mean value.
Oh, do the reverse one, right? Come on, Prerna. You already have this number with you, isn't it? This blue line, this number is 93.6.
Yeah.
You have just Z transformed it from your original value. What's the point of again transforming it back? You already have your information, right?
Now come again. What you just said? Come again. What you
have 93.6, isn't it?
Yeah, 90.
You just Z transformed that into this blue line or whatever line. Yes.
Okay. But for doing the, I think when we do the example, then it'll be more clear. I'm not getting.
No. You are a little bit confused at this moment. Just tell me your question, or maybe I am not able to understand your question.
So let's just resume with the explanation further on this example. I'll ask later.
No. I request you to just ask your question once. So you said it is 93.6. Please tell me your question again.
So I am saying that we did the Z transformation
for 93.6, yes.
On 92, the population mean.
92 and also 93.6, right? We have to do, come on, each and every
point. Oh, yes. Yeah, we did.
Every point we have to transform, right?
Yeah.
Just like how did we do this birth weight example? 141, we Z transformed it, isn't it?
Yeah. Okay.
That's how we checked it.
Okay, yeah. So sorry. Okay, go
No, that's fine.
Thank you.
But I hope the confusion is clear, right, Prerna?
Yeah.
All right.
So after this Z transform, when you draw the curve with respect to the blue line,
when you do the?
You draw a similar curve with respect to the blue line.
No, I'll not do that. So this curve that you're saying is the curve. Now I'll come to that. That's your second perspective. Now guys, listen to this, everyone. Let's remove everything now. Yeah, tell me.
We're taking mean of means.
Mean of means? When? Here? In this case, no. In this case, why will I take mean of means? Okay, fine. Okay, yeah. It's not mean of means. Yeah, fine. Tell me, yes.
So if we don't take mean of means, actually, for this average, to take average of average.
Who said that?
So if we sum it all and the mean will be different.
What are you talking? Why can't we take averages of average? See, average is just another point which is representing multiple points, isn't it? If someone gives you a straightforward thing, see, let's say if I ask you, hey, what's your score? What's your percentage in your 10th standard? So, yeah, you are a bright student. Yes. Yeah. So let's say you say that 65% is your score, right? So you did not say that you scored this much in English, you scored that much in chemistry, this much in physics, this much in, I mean, like, you have not given your all 10 subject marks. You told me one representation. So if I'm taking a sample, let's say I'm taking 2 samples. I asked you, you told me 65% straightforward. I asked her, she gave me the entire mark list. So like, ये mark list है, लो calculate करो, दफा हो जाओ. So here I'm taking mean of my sample. And likewise, I'm taking mean of a lot of students here, right? If everyone is submitting their mark sheet, not their final percentage, then I'll have no mean of means, right? Now let's say if everyone is giving you one score, like 65%, like all the 50 people are giving me the percentage at 65, 70, 80 or something. I don't have to find out your means, right? So that's what it is, as simple as that. The sample can mean anything, right? Okay. Now let's look at the other perspective. How about the samples that you have taken? How about the 50 samples that you have taken? So let's say you found out the petrol prices of 50, right? So what did I say about this from central limit theorem perspective? Mean of all means will follow a normal distribution, right? So now this is definitely going to follow a normal distribution, yes or no? All the 50 petrol prices, the prices collected from 50 petrol pumps, that is going to follow a normal distribution, yes or no? So this is what it is, right? If not exact normal, it will be at least near normal distribution with slight amount of skewness, that's it. Right? Now, in this case, now let's assume this point is 93.6. Correct? Now you're trying to prove whether this brown line is close or far. In this case, I'm taking only left hand side because I know whatever information that I have, it was 92, which was less than 93.6. So 92 can't be here, right? That's why I've taken on the other side. So you want to prove if you're looking at 90% confidence interval, so the z value comes up to be 1.645 something. So whether the z value of 92 now is really closer to 93.6 within like plus or minus 1.64, or is it away from it? If it is away, then your test fails. This is the other perspective. It's just that I have changed the points here. The black line is now 93.6, the brown line is 92. That's the only difference. This case I had used normal curve because I have all the rights to do so, thanks to CLT. In the previous case, I had used a normal curve because that is what my question was saying. Had that been, let's say, a hypergeometric curve, or let's say, not hypergeometric, it doesn't work on hypergeometric. Let's say that's a student T curve, for example. In that case, your perspective is going to change, but still CLT remains constant, right? Yes or no? So this is what it is. When we are considering different varieties of rice, taking mean of these values and overall mean would get rid of the variation. Should we proceed with such means? I didn't quite get your question, Siddharth. Why and how will we get rid of the variation? We will never get rid of the variation. We can't, right? There is a factor called variance and standard deviation always, right? So this is what happens. Like, let's say a shop is selling 20 different varieties of rice. There is still a variance over there in the price, right? There will be, obviously. Yes or no? So I hope you're able to understand now, right, Siddharth? Okay. Now that was my first point on confidence intervals. I hope that is understood. And the explanation again for your z-test, that is also understood with respect to confidence intervals. Yes, Now let's look at the next factor on hypothesis testing. What do you understand by hypothesis testing? So first of all, in hypothesis testing, you'll have to always come across two factors. One is null hypothesis, the other is alternative hypothesis. These are the two things which you have to decide on whichever hypothesis test you're doing. That's my first point. Is that clear? Decide on null hypothesis and alternative hypothesis. Right? Second point is, what's the alpha? Second point is decide on the alpha. Are you going to take 90%? Are you going to take 95%? Or are you going to take 99%? You will never take 100% CI. 100% CI is saying XYZ party will win 0 to 545 seats. No. 99 is like saying XYZ party will win either 20 seats or 520 seats. 20 to 520 seats. That's a bigger zone. 95%, a little bit lesser. 90%, even shorter. You will not go less than 90%. I hope you're able to understand that. If you're going below 90%, then that's a serious question on your accuracy, right? So what's your alpha? Is your alpha 10%? Is your alpha 5%? Or is your alpha 1%? That's the question, right? That's the next question. Now, once you have understood the entire concept behind confidence intervals, let's understand one small thing regarding alpha. Please listen to this concept. Okay, anyways, I'll just come to that. Let's look at the third point. I'll come to the concept of alpha in a while. Let's look at the third point. What's your test? Which test are you doing? Are you doing your z-test? Are you doing your t-test? Or f-test? Or chi-square? It all depends on what kind of scenario you are facing. Is that clear? 4. Based on the test, what's your score? So for z-test you have z-score, you have t-score. For ANOVA you have f-score. For chi-square you have chi-square value. Right? You have different metrics for different kind of tests. Say if you're doing k-means or any kind of segmentation, you have something called pseudo f-score. There are a lot of terms involved here, right? Is that clear? Based on the test, what's your score? Fifth point is that score lying within the decided CI or alpha. If you're looking at z-test, you know the values. That plus or minus 1.96 remains constant always. So x plus or minus 1.645, x plus or minus 1.96, and this is x plus or minus 2.57 something. Yes, this always remains constant. So is that score lying within the decided alpha? That's what you have to look at. How to look at? Here comes the concept of p-value. Here comes the concept of p-value. Your software will not show you all these things, whatever is happening here internally. You're just giving the output and you'll get an answer. You're just giving an input, you'll be getting an answer, and that answer is your p-value. I'm just marking it in blue so that you can understand that this is the most important part of this entire discussion. right? So your software will give you a p-value, right? Is that clear? Based on this p-value, we decide if we accept null hypothesis or what? Reject. Yes, reject null hypothesis. There is nothing called accept alternative hypothesis. It's always accept null hypothesis or reject null hypothesis. This is your entire hypothesis testing. Is that clear? First you will decide on the hypothesis, alternative and null. Decide your alpha. If you want to be a little bit more liberal, you will go for 90% confidence interval. So you are giving a chance for having some errors. It's okay. You're being liberal. Too strict is your 1% error. Yes or no? So let's say you're doing a SaaS clinical trial, pharmaceutical clinical trials. In those cases, they always take 99% confidence interval. Because life is always precious, right? Even if it is a mouse, life is precious always. So they're a little bit too strict about their computer simulations. A drug simulation tested inside a computer should have highest accuracy, right? This is your default moderate, 95%. Is that clear? So you will decide your alpha, then you will see what is your test. So based on the test, what's your score? And finally, is that score lying between the decided alpha or not? You will not look at it manually, rather you will look at the p-value, right? Now the concept here is, sixth concept is, based on this p-value, we will decide if we accept null or reject null. Is that clear? Is that clear? So if p-value is much less than alpha, if p-value is much less than alpha, p-value is, I'm just exaggerating that. If p-value is less than alpha, then you have to what? If p-value is less than alpha, then what you should do? Reject. Yes, reject the null hypothesis. And if p is more, if p-value is greater than alpha, you will accept the null hypothesis. And what's your seventh step? And this is the most important step. What do you conclude? Right? So if you are working at any analytics firm, your client is always important at the seventh. Your client is always interested at the seventh point. They are least interested in knowing whatever you have done. This is the point which is most important for your client, and this is called reporting. Right? What do you conclude? You will have to write one paragraph or statement or sentence or whatever stating your conclusion. Is that clear? Now if I am giving you a case study, I am only looking at the seventh point, and if I don't find the seventh point in any of the case study, then it's a resubmission. Same goes for linear regression, logistic regression, any regression you are doing. If I'm not finding the seventh point, that's gone. You have to resubmit it. No matter how much accuracy you get, it's still a bad project. Is that clear? Yes? Now the most important question is, what is null hypothesis and what is alternative hypothesis? Null hypothesis always talks about, null hypothesis always talks about equality. Sample mean equal to population mean. This is always your null hypothesis. So if I want to write an English statement for null hypothesis for this problem, what do you think that should be? An example mean equal to population mean, just an example that I have given. For this example, for this Melbourne petrol price example, what do you think will be my null hypothesis? Can anyone tell me? Null hypothesis test for equality. What are we trying to prove? 92, right? So what do we write here? What is the null hypothesis for this problem? The null hypothesis is the prices, the petrol prices in Melbourne is 92 cents per litre. This is your null hypothesis. So you're saying your population mean equal to 92. This is what you are specifying as your null hypothesis.
So we need to accept it.
Pardon?
We need to accept the statement.
Yeah, so accept or reject, it depends on whatever is your final p-value. But this is what your statement is in the first place. I hope everyone is able to understand what I'm saying, right? Now what is alternative hypothesis? The alternative hypothesis is population mean is not equal to 92. That's it. That's an alternative hypothesis. Or population mean less than 92. That is also an alternative hypothesis. Or population mean is greater than 92. That can also be your alternative hypothesis. I hope you are able to understand this. So this can be one possibility, this can be another possibility, and this can be the third possibility. Your alternative hypothesis is one among these three possibilities. Clear? If this is the case, then it is known as one-tailed test. If this is the case, then this test is known as one-tailed test. If you are looking at these two, that's a two-tailed test. I'm so sorry, I'm just mixing it up. So this is two-tailed test and this is one-tailed test. One-tailed as in you're looking at only one side of it, either left-hand side or right-hand side, either greater than or equal to. You're not looking at both, right? Two-sided, it can be anything. So let's say the petrol prices that you have calculated, let's say is 94, for example. I'll say that, hey, the actual petrol price might be greater than 94 or less than 94. If you're issuing that kind of a statement. So then it's a two-tailed test. Or if you're issuing a statement, like let's say the gold prices, for example. I say, hey, the gold price today is 3,500. So if you're someone who is regularly following gold, you say, hey, it is not 3,500. I'm sure that it is less than that. Is that clear? So that becomes a one-tailed test. One-tailed test on the lesser side. Yes? Or let's say if I'm saying, hey, the petrol price in India is 30 rupees. First of all, you'll slap me. And say like, hey, I know this is not 30 rupees. I know it is definitely greater than 30 rupees. See, now you have changed how you have changed your statement. You are never saying that it is not equal to 30. You are definitely saying that it is greater than 30. Right? And you'll get 1 liter of petrol and pour it on me. Right? Because I said it is 30 rupees. So that's again a one-tailed test on the right-hand side. Right? Or if I say, hey, petrol, the price of rice in Bangalore is 50 rupees. So you say, maybe it can be, because it can be 50 or it can be greater than 50 or it can be less than 50. If it is equal to 50, then it's my null hypothesis, right? If you're looking at the alternative hypothesis, you can say, hey, it can be greater than 50 or less than 50, I don't know. Isn't it? Is that clear? So now I hope all hypothesis testing is clear to all, right? Decide what is null and what is null and alternative. What's your alpha? What's your test? What's your score? What's your p-value? Are you rejecting your null or accepting your null? And what's your final conclusion? Right? Oh my God. When we are considering different varieties of rice, I think this is done. If we are doing all the tests like Z, T, chi-square, if not, then this case test has to be done. Pratyush, I'll come to that, don't worry. Books usually says that either you fail to reject or you reject. We never accept. No, nothing like that. Read multiple books, you'll come to know it. Maybe like some people, yeah, I mean like Prerna is not wrong at all, guys, jokes apart. You can issue a statement like not accept null or accept null, right? It's all about the statement that you're using, but we'll never use the word reject alternative or accept alternative. We'll never issue that kind of a statement. It always has to be with the null hypothesis. Either you accept it or reject it, right? But then if you carefully read it, her sentence, you'll say like fail to accept, or sorry, fail to reject, which means accept, right? Or you reject. I hope you're able to understand that, right? It all depends on the statement, but it has always to do with null hypothesis, not your alternative hypothesis. And when Prerna mentioned HO means null hypothesis. It can be mentioned as HO. I keep using this convention HO, or you can call it as H0. Or it is HA or H1. I hope that answers your question, Prerna. Yes, fail to reject or accept, it has to do with null hypothesis, not with the alternative hypothesis. Again, that's just a standard actually, just to not to confuse people, that's it. Right? A convention taken with null hypothesis. Now, let's do this entire test using hypothesis testing. Right? Let's begin one by one. No, after this test. So, what's your null hypothesis here? Santosh, let's not get into that debate. If you want to get into that debate, then that would really get nasty. I would always use the word accept. Accept and reject. I am an unconventional person, so I will not follow that convention, but I will always stick to null hypothesis, not alternative hypothesis. So most of the books that I have read, they are written by mostly American authors. And they have used this accept and reject. What we do in India is mostly done by the British statisticians. Right? So fail to reject and accept. So that's the thing. Anyways, what's a null hypothesis here? Step 1, the hypothesis. What's my H how for this petrol price problem? So mean of population. So mean underscore population equal to 92, because you are the one who has done sampling. According to you, you are always correct, right? So you are always checking for what other information you have, if it is correct or not, right? So 92 is the other information for me. 93.6 is my information. So I'm checking if I'm claiming that population mean equal to 93.6. Because this is what I have found out through samples. So you're trying to prove if population mean is actually 92, or alternative hypothesis is mean of population not equal to 92. I might say it is greater than 92, or I might say it is less than 92. I'm not interested at that now. In this question, I'm always interested at mean underscore population not equal to 92. Is that clear? Now, what is the implication of this? One-tailed and two-tailed. What is the implication of this? So here is when one of the questions that Prerna had asked comes into picture. Is it 5% on both sides? So 5 plus 5, does it make 10%? Or is it 5% on each side? I mean, is it 5% on each side? So does that make 5 plus 5 10% as your error? Or is it 5% on overall? So that makes overall error as 5%. So that depends on which kind of test you are doing. If it is a two-tailed test, it's 5 plus 5. Overall, it is 10%. So if I declare that my alpha is 5% and my test is two-tailed, right? Which means it is 2.5% on my left-hand side and 2.5% on the right-hand side. I hope you're able to understand what I'm saying, right? And if I say overall alpha is 10%, and I'm looking at only one side, then your overall error is also 10%. It's not 5 and 5 on both sides. It's 10% overall, right? But this comes into picture if you're doing a t-test, not in case of a z-test. Clear? Now, second thing, you have decided your HO and HA. What's your alpha? Here I'm just deciding my alpha to be 5%, 0.05. I'm taking the moderate one by default. I'm not going liberal, I'm not going strict. I'm being moderate, that's it. Third point, what's your test? What's your test? Now tell me, what is my population? 50. Is 50 greater than or equal to 30? Yes. Do you have your existing population information? Existing population information, is it known? It's known, right? You know your population mean. You know, first of all, you know that it's normally distributed. That's one information that you have. Second, you have its mean. Third, you have its standard deviation. You have everything about your population. What's the big deal? Nothing, right? So population information is known. So what's your test now? Z-test. Right? So what's your score? What should be the score? It's a Z-score. How do you find out Z-score? So X minus mean by standard error. That's your Z-score. And because for your samples you don't have standard deviation, you have standard error, right? X minus mean by standard error, which means X is your sample mean minus mean is population mean, because I have both the things, right? This entire thing divided by, what is standard error? What is the formula of standard error? I'm so sorry, I'm so sorry, I gave you a very wrong information here. I stand corrected. Standard error is not standard deviation by sample size. It's standard deviation divided by square root of sample size. I stand corrected here. I'm so sorry. Please make a note of the correction, what I've told you in CLT. Standard error is population standard deviation divided by square root of sample size. So here, mean of sample minus mean of population divided by, yes, what is my standard deviation? So standard deviation of population divided by square root of 50. Why square root of 50? That is what is my sample size n. I hope everyone is able to understand this. Yes? So we want to write it down. I'll just write it down. So Z score for Z test, so that's equal to your population mean, mean of sample minus mean of population divided by, yes, standard deviation of population divided by square root of sample size. Is that clear? So what do you get in this case? In our case, we will get this as 93.6 minus 92, this entire thing divided by, what is standard deviation? 3.1 divided by square root of 50. That's our formula. Clear? So let's calculate that here. That will be equal to 93.6 minus 92 divided by 3.1 divided by square root of 50. This bracket close, this bracket close. 3.64. That's my Z score. Z score is equals to 3.6. right? Now, what was my alpha? So, which means that should lie between minus 1.96 and plus 1.96. I hope this point is clear. So your z-score should lie between plus 1.96 and minus 1.96. Right? That should be your range. What's your z-score now? 3.64. Where is 3.64 coming? Here or here? The first one here, right? This is your position. So is it away from this position or within this position? Away, right? So what will you conclude here? Fifth question. Is the z-score lying between the confidence interval? What is your answer? Nope. What's your conclusion? Now what? What to do with the null hypothesis? According to Prerna and Santosh, what do you do with null hypothesis? Did we fail to reject or did we reject? Did we fail to reject or did we reject? We rejected, right? So we reject the null hypothesis. Or should I say, according to their language, we failed to reject null hypothesis, right? Yes? The failed to reject null hypothesis thing, yes? Actually, that thing got me psyched up at this moment. So we reject the null hypothesis. We don't accept it. That's it, right? Simple words. So what's your final conclusion? This is where your English skills should kick in. And what should you conclude? The petrol prices in Melbourne is not 92 cents per liter, rather it is significantly different, and Melbourne is a very beautiful city. That's your final conclusion, right? Use bicycle. The earth is getting polluted day by day and you should prevent global warming. That should be your conclusion. Write whatever you want to write. Yes. Yeah, I'm not kidding actually. Like if you look at if you happen to meet anyone working in McKinsey or any kind of consulting firms, they're more than your, I mean, like, why do you think, look at any LinkedIn profile of any person working in McKinsey, why do you think they will put MS Excel and MS PowerPoint as one of their skills? And that they keep getting those recommendations, or what do you say? What do you call that? When someone plus ones you on those skills? Endorsements, yes. They have high endorsements on MS PowerPoint. Why do you think so? The seventh step is the most important step actually. And that's why you're using a tool like Jupyter. Even R started using a tool like Jupyter. Right? So 7th point is important. And I hope the entire exercise is understood by everyone. Online guys.
Sumita, I had a doubt.
Yes, Prerna, please tell me.
So this is regarding the alternate hypothesis. So you just said that for not equal to cases, you'll have a two-tailed test. I mean, so if it is a 95% confidence interval, you'll have 0.5 on either side, right?
No. Let's say for a two-tailed test, and everyone please listen to this. For a two-tailed test, okay, why am I confusing you? I'll show the picture here. Just a moment. That's your confidence intervals. Students T, when to use, hypothesis testing, p-value. Yeah, here we go. So Prerna and everyone, please listen to this. If I say that I have a confidence interval of 95%, so what's my alpha? 0.05? Yes or no? Point number one. Point number two, if my alpha is 0.05 and I'm doing a two-tailed test, then it is 0.25 on either sides. That's your alpha distribution. I hope that's clear. Yes? Now if someone says my alpha is 0.05 and I am doing a two-tailed test, which means it is 0.025 on either ends. That's it, as simple as that. I hope that's understood now. Everyone? Prerna, is it understood?
Yes. My doubt is regarding the one tail thing. Actually.
So if it is one tail and you say that it is 0.05 alpha, then it is 0.05 alpha.
On one side, right?
On one side.
Okay.
Because either side is out of question now, because we are not looking at this part. Please look at this. You are just blinding this part off, right? So if you're saying alpha of 0.5, it has to be here only, right? Yes or no? Right? So this is what it is. Is it understood now?
Yes, thank you.
So we're taking alpha. We are not taking alpha as alpha by 2. It's like the overall alpha, if it is 5%, then it is distributed on both the ends. Pardon? If it is 10% alpha and it is a two-tailed test, it is 5% on both the sides. 0.05 here and 0.05 over here. That's how it is. So finally, your p-value is probability that a randomly picked sample will have the mean lying outside the confidence interval. So that's why we have this famous saying: if p is high, null will fly. If p is low, null will go. Or did I say the opposite one?
You just said the opposite, Sumit.
I said the opposite one, yes. If p is high,
so if P is low, null has to go. That's the same.
P is low, P is low, null has to go, yes. If I have very less p value, if p value is less than alpha, then you will be rejecting your null hypothesis, right? If p is less than alpha, you are rejecting your null hypothesis. That is what it is. Yes? Alright. So I hope this example is understood to all, right? So 3.65 is way outside your confidence interval, right? It's in the rejection region. So reject your null hypothesis. That's it. Pardon? Have I not shared this file? No, I have not shared this file, right? No. So I'll share it today along with the codes. All right, then let's take a break of 10 minutes. That's what I'm saying. So yes, please go ahead with your question.
There's one more file that you haven't shared consistently is that notepad. And sometimes you share it, sometimes you don't. Last time you shared that the DSP
Actually, what
September
happened
18th.
is, you remember, the system suddenly got shut down.
Yeah.
Since then, I have not been able to put a proper track of this notepad.
I see.
But nonetheless, you have everything in recording, right? So whatever I'm typing in the notepad.
Okay.
So I hope that should help. And second, I'm anyway sharing the codes. And third, for statistics, we'll be sharing these PPTs, not just that. Whatever we type, and mostly now we'll be typing things in Excel. So these Excel sheets we'll be sharing. So like this is today's sheet. I'll definitely be sharing this sheet. Because other examples also I'll be putting in the sheet, right? So I'll be sharing this sheet as well.
Okay.
So don't worry about that.
Anthony?
Yes, sir. What's your doubt?
So the example that you mentioned,
Mm-hmm.
the hypothesis says it's not equal to 92, right?
Mm-hmm.
And we found out that, in fact, equal to 92.
Mm-hmm.
Which when we found out that you're rejecting it, which means it is not equal to
Not equal to 92.
So just going to next says the null hypothesis means that your sample mean is equal to your population. Is that what it is?
Yeah, not just that. I mean, if you're looking at the perspective of z-test, yes, you're absolutely correct.
Okay. So in that case,
So in general, if I want to talk, see, null hypothesis is used by null and alternative is used by any hypothesis testing, right? And not all hypothesis testing is all about means. There can be variances. There can be, I mean, like if you're talking about categorical variables, there'll not be mean and variance. There'll be something else, right? So it all depends on scores.
right. So in this case,
So let me complete. In general, null hypothesis is all about checking equality. Equals to sign, if it is there, then that's null hypothesis. Not equals to or greater than or less than, so that's your alternative hypothesis. That's one rule which you have to always remember. And that's the reason how you design your cases. Maybe like after we discuss our F test and maybe chi-square test, we'll be able to know what we are talking about, right? Yes.
so in this case, your null hypothesis states that is your mean of your sample equal to your mean of the population, and you're rejecting that based on our test. Would that mean that either of them has an error? Maybe the sample is not correct.
Exactly. So because you are the one who is control of the sample, according to you are always correct, right? So you are taking the sample, hence you will blame it on the population. You'll say whatever population information they have given me is incorrect.
Is there a possible test to actually?
No, it depends on the situation. That's it. There is no test for that. There is no test as such. This is the only test. So either you are looking from sample perspective or you are looking from the population perspective. Right?
And what if the central tendency is not mean?
Central tendency is not mean. That's a big thing. So that's the reason why, like you will just come to know about it. Whenever we are doing linear, logistic, or anything, one of the assumptions in linear regression is there should not be any outliers. You have to ensure that your mean stays closer to your median. Symmetry. That is what you must ensure, right?
So what if we say that my mean is, so in this case, it says mean in 92. Suppose it's that mean is less than 92.
So that means let's say you're rejecting null hypothesis in that case, you'll conclude that petrol price is less than. So I've told you an example, right? What if I randomly come and say that in petrol prices of India is 30 rupees? What will be your immediate statement? Hey, that is not 30. That will be much greater than that. So see, you're not even saying that it is not equal to 30. Instantly, you're saying that it is greater than 30, the actual price, right? So that's a one-tailed test on the other side, on the greater side, right? That's understood? Okay.
So what's the importance of alternative hypothesis? Why do we have that when we're not using it?
Hey, we are using. So that's one definition which you have to write it, right?
Yeah. So from a definition point of view, saying it's greater in this case, greater than or less than.
And also it talks about. I mean, like let's say the next t-test example, you'll understand why. What's the importance of setting your alternative hypothesis, right? Now, in the next example, what I have is this. Okay. This was the z-score that we have calculated. Everyone is aware of this formula, right? Now, listen carefully. When did we use z-test in the first place? Our two conditions had to be satisfied. Population information is known and sample size is greater than 30. What if, let's say you have population information, right? And let's say the sample size is less than 30. What if it is 10? And you have still performed this test. What are you getting your z-score as? Z-score is 1.63. First point. 1.63 lies between plus or minus 1.96. Yes. So what you are doing, your entire test has got reversed, right? You are accepting null where you had actually had to reject it. If I say petrol prices in India is 50 rupees now, and you take only two samples, maybe you ask two petrol pumps. Let's say they have sarcastically replied, yes, the petrol price is 50 rupees. Finally, what did you do? You accepted your null hypothesis, right? Whereas you had to reject it business-wise, because you know that petrol price in India is not 50 rupees at this moment. I'm just giving an example. So this kind of an error happens when you're doing the wrong parametric test. Your parametric test, sorry, not parametric test, I'm so sorry. When you're doing the wrong test, here the test is not supposed to be a z-test if my population is less than 30. Is that clear? I should not be doing a z-test if my population is less than 30. Point number one. Point number two, the fact that you are accepting null when you had to reject it, or you reject null when you have to actually accept it, these are known as type errors. If you accept null, sorry, if you reject null, if you reject your null hypothesis when in actuality you had to accept it, that kind of an error is known as type 1 error. Right? You reject null when you're supposed to accept it, that's your type 1 error. You accept null when you're supposed to reject it, like in this case, that's your type 2 error. Is that clear? Type 1 error and type 2 error, type 1 and type 2 error. So this is one level of errors that we will be commonly seeing in hypothesis testing. Is that clear? Little bit if you go deeper into modeling, you will have a slight variation in these definitions of type 1 and type 2. There we will call it as overfitting and underfitting. Here we will call it as type errors. Is that clear? Guys, can anyone repeat what did I just say? Online guys and classroom guys. What is the type 1 error? We reject null when we were supposed to accept it. That's type 1. What is type 2? You accept null when you actually had to reject it. Right? I hope that's clear now, Uttam. Okay. Example 2. Please look at the statement very carefully and just let me know what you have understood with this. Now it's less confusing, right? So if you have read this question, just tell me the parameters, whatever we have here. Sample size, fantastic. Yes, sample size is 15. Standard deviation of what? Fantastic. And mean of sample. What's my population mean? Very good. Please read the question again. Exactly. Online guys, what did you conclude? Please let me know through your chat, or can turn on your mic and speak, please.
So Sunit, in the second statement, it mentions that the sample size is 15, the sample mean is 670, and standard deviation is 58, right? But in the first statement, it is unclear that it is the mean of the population at this company or not, right now.
Okay, so 630, it's not clear if it is population mean
or not. Yeah.
What is that 630? Yes?
Yeah.
Okay, let's continue with that discussion. But tell me, what are we trying to prove here?
So we are trying to prove if the regular wage should be 670 or not.
Okay.
The companies pay is it 630 or not? Is it justified?
So per week pay, is it 630 or not? Okay. Anything else?
Is it justified?
Is 630 less or is 630 more? Yes, I'll fix to that.
Yes, yes.
That is my thing. Can anyone say anything alternative to this? I mean, like, I'm just asking. Let's break this down one by one. Okay, I'll take over. Just a minute. Okay. Pratyush, there is a small correction. Let's look at this. Now, let's say you're working for a company, and let's say that's an IT firm. Are you the entire population? No, right? You're just working for one small company. That's it. I mean, like the entire strength of that company is a very small portion of the entire strength, what is known as your IT industry, right? So and you're getting 630 per week. Is that the population salary? No, right? That's the salary that they're giving you. I hope you're able to understand that, right? Let's begin this. So there is a factory. Let's call it as A, which belongs to, let's say shoes industry. Let's say it's a shoes factory. The workers get 630 per week, right? Does that mean that every worker who is working in shoes industry is getting 630? No. I hope we're able to understand it, right? So all those you think 630 is the population mean? No, it is not the population mean. This is not the population mean. Right? From this question, what is population mean? We don't know, unknown. Right? Now, the workers are claiming that, what's the problem now? What's the business problem? Now, the workers are claiming that the 630 that they are receiving is much less than the industry standard. So, 630 is less than mean of population. Industry standard salary means the average salary received by everyone who is working in the shoe industry. Yes or no? Now, they can't just give blatant statements like this, right? They have to back it by some statistics. What's the business problem? This is the business problem. Workers claim how did they claim it? How did they conclude this? I took a sample of 15 people. Mean of sample came up to be 670 plus or minus 58. Yeah? Yes or no? According to them, so what? According to the samplers or according to the workers, industry standard salary, or in our case, mean of population is equal to 670 or greater than, okay, greater than equal to 670, which is not certainly less than 670. Yes or no? What they're getting in the industry is certainly not less than 670. It is equal to or greater than. So what should we do? What should the management do? It should increase the price to 670. because this is what the entire population is getting according to the sample that they have collected, and this is what we have to prove. That's it. This is all what we have to prove. Is that clear? 630 is one of the points in the entire population. It is not the exact population, but it is one of the points. It is one of the X in my entire population. Is that clear? Yes? Clear, right? Okay, now let's see how it is done. So first of all, null and hypothesis, null and alternative hypothesis. What is our H0, HO? What should be our HO? Pardon? So our alternative hypothesis is, now what is happening is, what next as the management? So as management, we try to prove that our salary is equal to industry salary. I hope you're able to understand it, right? Our salary equal to industry salary. 630 is the industry standard. That's what I'm saying. So tell me, what is your hypothesis now? Can anyone tell me can anyone help me out with the alternative hypothesis, guys? What should be your HO?
Mean population is 60.
Pardon?
Mean population is 60.
Population mean underscore population equal to 630. Fair enough. So what is the alternative hypothesis?
Greater than 60.
Exactly. So alternative hypothesis is something which we are looking at the worker's perspective. What would the workers say? Workers would say, what is the industry standard or mean of population or the industry standard? Whatever other people are getting in the shoe industry is much greater than 630. I'm not saying not equal to, I'm specifically saying that it is greater than 630. What is 630 here? 630 is the salary what these workers are getting now. What are they trying to prove? They're trying to prove that the mean of, what are we trying to prove about their claims? We are trying to prove that whatever 630 we are giving as an industry is according to the industry standard. What we are giving to the workers is according to the industry standard. What are the workers claiming? Is greater than 630. Whatever we are giving them. Is that clear? Right? Now, how much alpha do you want? How much alpha? So in this example, I'm just changing the alpha. I can take 95% confidence interval. No doubt about it. Just for the example's sake, I'm just taking alpha is equals to 0.1. Is that clear? So my alpha is equals to 0.1.
So doesn't my conclusion change with?
Yes, it changes. The conclusion changes with alpha. I'm being a little bit more liberal to my employers. There are more chances if my alpha is increasing, decreasing. Sorry, alpha is increasing or my accuracy is decreasing. I might end up rejecting the null hypothesis. Let's see what happens. So that's the reason why I have taken this as an example. Just to see what happens if we reduce the confidence interval or if we increase our alpha. Now tell me one thing, what kind of a test is this? Yes. What's the test stat? Do we know population information? Nope. Is the sample okay? So one is no, and the entire thing is a nope. Actually, you can't use a z-test. But still, is the sample size greater than 30? Nope again. Who knows? Which means no z-test. Then which test? T-test. Now what kind of t-test? Fantastic. So t-test, yes, please. But one tail. Why one tail? Because I'm looking at only one side, that's it. Greater than 630. Now, for t-test, what's required? What's all required for t-test? So t-test means you're following a t-distribution, you're not following a z-distribution. Whatever I said about confidence intervals, it holds true for a z-distribution or a normal distribution, Gaussian distribution. A t-test follows a t-distribution, which is not similar to your Gaussian distribution or normal distribution. So t-test will completely change the perspective, right? So what is all required for t-test? We need a t-score. A t-score is exactly similar, x minus mean by standard error. That remains constant. There is no change in that. It's just that the formula of standard error changes. Let's see what is that later. Second one, you need degrees of freedom. So you already have alpha. You need degrees of freedom. You need this something called degrees of freedom. Let's say you are at your house, you're staying in your house, or you're staying at whatever place you belong to. And if you want to go out, let's say you want to go to office every day, you do have a lot of choice of your dresses, right? Your entire wardrobe is with you, right? You don't want to wear your blue shirt, wear something else tomorrow. Yes or no? Let's say you're on an office trip for 5 days to a place. Can you carry your entire wardrobe there? No. You're just taking a small sample of your wardrobe. Not sample. Few dresses, that's it. Let's say you're taking 5 shirts, which you have to wear every day for 5 days. Right? So whenever there is limited amount of data points available, it so happens that each and every point will affect the presence or absence of one point will definitely affect the other points. I hope you're able to understand it, right? Here the workers had a sample of only 15 people. Even if somebody is going out of the equation, if let's say somebody said like, okay, I gave you the wrong information, this is not my salary. So you're removing it and making it 14. That will affect the entire results, yes or no? So hence there is a concept of degrees of freedom whenever it comes to a t-distribution. The formula of degrees of freedom is as simple as n minus 1. N is your sample size. If you're taking a sample size of 10, your degrees of freedom is 9. So understand this by the shirt example that I'm about to tell you. So you're taking 5 shirts for a 5-day meeting outside your city. Yes. Day 1, you're wearing 1 shirt and you can't wear it in the next day because it gets soiled and destroyed. Like you can't wear it. It will not be in a position to wear it. So let's say you're wearing a shirt on Monday. How many options do you have for the next day, Tuesday? 4. Very good. Let's say Tuesday is done. You have used 2 shirts. On Wednesday, how many options do you have? 3. On Thursday, how many options do you have? 2. 2 options you still have, right? On a Friday, how many options do you have? 0 options. On a Friday, you have no option at all. You have only 1 shirt remaining. You have to wear that at any cost, right? Right. So degrees of freedom is n minus 1. Total number of samples minus 1. That's taken as degrees of freedom. And this is what is required for our t-test. Is that clear? Yes? Okay. Now what do they give? They provide us with the limits. The above information provides the limit or confidence interval. Is that noise? Okay. So this above information provides the confidence interval. How? Let's see it. In our case, What is my alpha? I said alpha is 0.1. What is the degrees of freedom here? How much sample do I have? 15. What is degrees of freedom? 14. Now we will have to look up our t table. So please pay attention. I'm opening the t table. This is your t table. See, on this end you have df. What's your degrees of freedom for all the sample? This is a limited table, so I have only few numbers here. Is it a one-tailed or is it a two-tailed? Yes. So all these things you have. This is the first level of information that you have to see. First of all, what's my df? 14. So I'll have to look at this row. This is the row which I have to look at. Now which column I should look at? Tell me one thing. Is it a one-tailed test or two-tailed test? It's a one-tailed test. What's your alpha? 0.1. So what is your overall alpha if it is a one-tailed test? See? Sorry, overall confidence interval is 90%. Yes or no? If it is a two-tailed test and my alpha is 0.1, what is the overall? What is the overall probability? 95%. If my alpha is 0.1 on both the tails, it is 0.5 on each of the tails, which makes the total confidence interval at 95%. But that is not the case here, right? It's a one-tailed test and I am taking my alpha as 0.1. So what's my overall frequency? What's my overall probability? 90%. Degrees of freedom 90%. 1.345. Right? If the degrees of freedom is 14 and it is a it's a two-tailed test, let's say, and my alpha is 0.1, the value comes up to be 1.761. So it's minus 1.671 on my left hand side and plus 1.761 on my right hand side. That is where I'll be looking at the acceptance region. Anything beyond this is rejection region. Here in my case, what's my score? 1.345. Please look at this diagram here. Anything beyond 1.345 is my rejection region. Yes or no? Anything within this zone is my acceptance region, not the entire zone. Please look at this. There's a small mistake here. This zone. This is my acceptance region. I hope everyone is able to understand how a t-test works, right? Online guys, is this clear? This is my acceptance region. This blue color is my rejection region. Online guys, is this understood by all?
So Sunit, it is from left till the right? I mean, why have you put this black thing?
Pardon?
I mean, it is from the left tail till here, right? Why did you put this black thing? I mean, it's showing the
there
pink.
There is nothing called left tail. I mean, like, yeah, there is left tail and right tail, but here in this case, greater than, right?
So the pink line is showing us the acceptance region and the blue region is the rejection region, right?
Yes.
From the left to this particular point, 1.3.
Not entirely left, but yeah, I would look at only half of it. I mean, like, I wouldn't be looking at the entire thing.
So that's what my question. Why are you only looking at half of it?
So, okay, why are we looking at half of the thing? So, I mean, like, I might be wrong, but only thing is, I'm not. See, if this is my central point, if this central line is 630, or let's say, so industry standard should not be less than this one, right? Or let's say if the central line is industry standard, what I'm basically looking at, 630 is equal to, right? That's why I'm not looking at that reason. The picture that you're seeing here without all these things, it's a general picture of acceptance and rejection. Anything below this is a rejection, anything here is a acceptance and such things, right? But in any ways, if you just forget that for a moment, 1.345 is your line, right? That's your cutoff. Right? Anything greater than 1.345, you reject your null hypothesis. Is that clear? Okay. So let's see, this is your t-score. 670 is your sample mean, so I'm just writing the formula here. T-score sample, okay, mean underscore sample, right, minus a certain hypothesized value, right? So in our case it is 630. Why? Why it is 630? Why did we consider hypothesized value as 630? Because that is our base salary, right? That is our base point, right? That is the salary which we are offering. So that's the hypothesized value. That's a fixed value. Yes or no? Entire thing divided by. Now here, standard error is, please look at the way how I have used a small s. So I'm now looking at the sample standard deviation, STD of sample divided by n. N is your sample size, square root of n, sorry, where n is your sample size. Is that clear? N is always the sample size, right? Here also n is your sample size, right? This is what we have written here, right? So what is my sample mean? Sample mean is 670. The hypothesized value is 650. Sorry, 630 divided by 58 divided by square root of 15, yes. So the value after calculation comes up to be 2.67. So is 2.67 less than or greater than 1.345? It is greater than 1.345, right? Which region this is in? Rejection region. So what did we do next? So what's your what's the cutoff? 1.345. What's the t-score? 2 point something, right? How much? 2.67. What do we do now? What do we do with the null hypothesis? So we reject the null hypothesis, right? We reject the null hypothesis, or we fail to accept null hypothesis, right? Clear with this? So what's your conclusion then? What's your conclusion? Yes, the workers are not paid according to the industry standard because the current salary of 630 is less than the industry standard salary. Hence, there must be a hike in the salaries as claimed by the union. Yes? Before we leave, just to give you a perspective for chi-square and ANOVA, see here till now we are dealing with continuous variables. Continuous variables for z-test and t-test. So whatever two tests that we have done, they are one sample test. They are one sample test or paid sample. There can be paid sample test or two sample test. I'll not use the word paid, I'll rather use the word two sample test. One sample test, what did we do? Both the cases, mostly we have done a one sample test. You have had one sample of 50 or 15 and you checked against a hypothesized value. In my first case it was 92, in this case it is 630. Yes? Two sample. So here, sample versus population. Right? Two sample is sample versus sample. Two sample test. It's always sample versus sample. I hope you're able to understand what I'm saying, right? Yes? Let's say the government has done a sample. Average salary of Bangalore. This is they're deriving it from a sample, right? Let's call it as govt underscore sample. Right? You are also taking a sample, like let's say my underscore sample. Again, same average salary of every household in, or average income, household income in Bangalore. Both are samples, right? Yes. Let's say they come up with a figure of 4.6 LPA. Let's say that's what the government has concluded. And let's say your survey says that it is 5.1 LPA. You want to check if this information is correct or this information is correct. Because according to you guys, both the things are your population. Which one is actually correct? So is 4.6 significantly different from 5? Is 5.1 significantly different from 4.6 or not? I hope you're able to understand what you are testing here, right? This is also a two sample test. This is also a t-test or z-test, whatever you can call it. Yes? Next up, you have something called independent sample t-test. Independent sample t-test. What do you understand by this now? So here is where one categorical variable comes into picture. One categorical variable versus a continuous variable. And one binomial categorical variable, that is one binomial categorical variable. Only two categories. For example, the best example that I can give you here is, let's say, use of, for example, Paytm. Use of Paytm, for example. You have 200 samples, 200 people. You have randomly 200 people, or let's say you have randomly 2,000 people, for example. You want to check, you have a group called gender, male and female. You want to check out of these, you want to check if male and female are having the same usage pattern of Paytm. Is the usage pattern of male and female same or different? So what do you say? Average spent in Paytm for males equal to average spent by females. So then you'll conclude that both are having the same usage pattern, which is quite true, right? Is there any difference in the patterns? This is not a handbag example. This is another example where both the groups will have similar kind of trends, isn't it? In real life. So this is what you want checking using statistics. This kind of a test is known as independent sample t-test. Both the samples are mutually exclusive, right? I hope you're able to understand, right? Male and female are completely different. Still you are trying to see if that sample and this sample mean are significantly different or not. I hope you're able to understand what I'm saying, right? So that's an independent sample t-test. Clear with this? Now, I have specifically mentioned that it's a binomial categorical variable. What if it is a multinomial categorical variable? What if there are more than 3 groups? What if, let's say what if we consider region, north, south, east, west, and Paytm usage. We consider region and Paytm usage. Now what happens? Can we use t-test? The straightforward answer is no. Nope. We can't use the t-test. What should we do in this case? Here is where your f-test comes into picture. F-test, or otherwise famously known as ANOVA. Right? F-test or ANOVA, that comes into picture. Right? Clear? And there is no longer mean. There is no mean, there is no median. What is there? We'll discuss that tomorrow. And what if variables, what if the 2 participating variables are completely categorical? So if I ask you a question, I have education qualification and I have salary bracket. Education qualification, salary bracket. So education qualification can be bachelor's, master's, PhD. Let's say, for example, I have 3 categories in education, and let's say I have 4 salary pay scale. Pay scale 1, 2, 3, and 4. 1 being the highest, 4 being the least. So does your educational qualification affect your pay scale? That's my question. So both are categorical variables. You have to prove yes or no. Does your gender affect your pay scale? Ideally it shouldn't. We'll have to test it, right? That thing is known as chi-square test or Pearson's chi-square test. This we'll be discussing it tomorrow, right? Along with linear regression. Yes? Clear? Let's meet tomorrow.